Hello everybody and welcome to Math 245. My name is Amanda. I use she, her, hers pronouns, and I'm so excited to be teaching you this term. So here is lesson 1. We want to solve a system of linear equations by graphing. So our learning objective here is to solve a system of linear equations in two variables by graphing. That's what we are doing in this lesson. So our first example is we want to solve the following system of linear equations by graphing, and we want to mark the solution on our graph. So first of all, a system of linear equations simply means that we have more than one linear equations that we want to solve. So a system means more than one. And we have two equations here. Y is equal to negative x plus 7, and y is equal to 2/3 x plus 2. So we are going to graph equation 1 by plotting points on our graph. So we could plug in any x values that we want to, but there are some easier ones that we are going to be doing. So if I make x equal to 0, then what would y equal? Well, in order to find the y value, this would be negative x, so that's negative 0, plus 7, which is just 7. And then if I were to plug in, say, x equals 4, what would our y value be? Well, I would plug in x equals 4 into my equation. That would give me negative 4 plus 7. Well, negative 4 plus 7 is equal to 3. I just need 2 points in order to plot a line for our linear equation. So this is good enough for me. I can plot these 2 points, and then I can draw a line between them, and that will be this line. So I'm going to plot the point 0, 7. So our x value is 0, and our y value is 7, so that point is right here. And then my other value is when x is equal to 4, and y is equal to 3. These are the 2 points that I found by plugging in 2 x values into my equation. And now I can simply draw a line connecting them and draw an arrow on either side. So my line will look something like this. So this is y equals negative 7 plus x. That's our first one. The second equation, we are going to graph using the y-intercept and the slope. So my y-intercept is the number that does not contain an x by it. So this 2 is our y-intercept, and that is the y value when x is equal to 0. So we have the point 0, 2. That is what the y-intercept tells me. So I know that I have the y-intercept, the point 0, 2. So that will be 0, 2. And then the other number, in this case 2/3, represents the slope. So here, our slope is 2/3. And we can pretty easily graph this kind of equation by using these two things as well, our slope and our y-intercept. So the first thing I'm going to do is I'm going to put our y-intercept on the graph. So my y-intercept is this point 0, 2 here. And then I have the slope 2/3. So what that means is that I'm going to go to the right up 2 over 3. So I'm going to go up 2 to the right 3. So this is going to be my new point. So a slope of 2/3. Remember, slope is rise over run. So this means that my rise is 2, I go up 2, and my run is 3, so I go to the right 3. So this gives me the point 5, 4, and now I have 2 points, so I can again draw a line between them. And this gives me a pretty good idea of where my two graphs intersect each other, right? So I can see that right here, at the point 3, 4, that's 3, 4, is where my two graphs intersect each other. So that is what we call the solution. The solution is where my two graphs intersect each other. So here, my solution is 3, 4. But our graphs aren't always going to be super precise, so I want to make sure that this is the correct solution by checking it. So in order to check our solution, I plug in this 0.34 into both equations to make sure I get the same answer. So let's plug into equation 1 first. So I want to check y equals negative x plus 7. Well, my y value, I'm plugging in this point, so I'm going to plug in this y value 4 equals negative 3 plus 7. Well, this is true, right? 4 is equal to negative 3 plus 7. So that is good to go. And then I want to check my equation 2 as well, to make sure that this point does lie on equation 2. So I am going to, again, plug in this point into my equation. So I have y equals 2/3 x plus 2. And if I were to plug this point in, I get y is equal to 2/3 times 3 plus 2, and our y value is equal to 4. And this is true because 2/3 times 3 is just equal to 2. So I get 4 is equal to 2 plus 2, which is also true. That means that the solution 3/4, since it satisfies both of my original equations, is in fact our solution. I want to pause here and say real quick that at any time, if you have any questions about the material or about an example that I did during these lecture videos, please do not hesitate to email me. I would be more than happy to answer any of your questions. I know that it's really great to ask questions in class, and I really encourage you to ask questions during class, but in this case, that just means that you'll have to email me your questions. I am also going to be posting a discussion board for each day's lessons, so you can also ask questions there. The TA and I will be monitoring that board pretty closely. So you have two options to ask questions: either email me or your TA, or post on the discussion board. All right, next we want to solve this example by graphing. So we are going to be doing the same thing that we did in the first example. So I have two equations here. Negative x plus 3y is equal to 9, and 2x plus y is equal to negative 4. The difference, though, between these two equations and the equations that I had up here is that these two equations were already in the form y is equal to mx plus b, which made plotting points and using the the y-intercept and the slope relatively straightforward. But here, we are not in the form y equals mx plus b yet. So the first thing I need to do is I need to get these two equations into the form y equals mx plus b. So let's look at equation 1. We have negative x plus 3y is equal to 9, and I want y equals mx plus b. So I want the x on the other side, so I'm going to add the x to the other side. This gives me 3y is equal to x plus 9. And now, in order to solve for y, I am going to divide both sides by 3 to get y is equal to 1/3 x plus 3. So this is y equals mx plus b form for equation 1. And then we have to do the same thing for equation 2. So right now, equation 2 looks like 2x plus y is equal to negative 4. And again, I want the x on the other side, so I'm going to subtract 2x from both sides to give me y equals negative 2x minus 4. Now I have both of these in the form that I want, so I can plot 2 points, or I can plot the graph using the y-intercept and the slope. So I'm going to do equation 1 through plotting points. So let's look at some x and some y values for equation 1. Let's say I plug in x is equal to 3. Well, if I plug 3 into here, this would give me y equals 1/3 times 3 plus 3, which is equal to 1 plus 3, or 4. So this y value will be 4. That's one x and y value, and then I want to find another one as well. So I'm going to plug in the point 6. So I need to find my y value. This is going to give me y equals 1/3 times 6 plus 3, which is 2 plus 3, or 5. So now I have 2 points that I can plot on my graph and then draw a line between them. So I have the point 3, 4 and 6, 5. And I can draw a line between them and extend in both directions. That's equation 1. And then for equation 2, I want to look at my y-intercept and my slope. So again, this -4 is my y-intercept, and this -2 is my slope. So I know that I have the y-intercept at the point 0, -4, so we can go ahead and draw that on the graph. It's right here. And if I want to graph the slope, well, I know that I have -2 is equal to rise over run. But we don't have a run here, right? We just have -2. So another way to think about this is -2 over 1. That means that I go down 2 and over 1. So here I'm going to go down 2 over 1, which gives me a point there, and then I can go down 2 over 1 again. So this gives me a line that looks just like this. And here it's not super obvious where my graphs intersect, right? Most of the time in this class, we will have pretty nice solutions. So it's not super obvious where they intersect. So let's try to make it a little bit more exact. All right. Ooh, okay. So let's see. I'm going to go over 3, down 1, over 3, down 1, over 3, down 1. And then over on this pink one, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Sometimes we have to be a little bit more exact. But now I can see pretty clearly that my solution is at this point right here, which is the point -3, 2. So this tells me that my solution is -3, 2. But again, I want to check that this is the solution by plugging in this point into both of my original functions. And in order to make sure that we did this algebra, this right here and this right here right, I'm actually going to plug in this point into our original equations right here. So let's see, I have -x plus 3y is equal to 9. I want to make sure that this is true. So this will give me -x, that's -3, plus 3 times 2 is equal to 9. Well, this gives me 3 plus 6 equals 9. That is true. So our solution satisfies the first equation. Now I want to make sure that our solution satisfies the second equation as well. So I have 2x plus y is equal to -4. This gives me 2 times -3 plus 2 equals -4, which gives me -6 plus 2 equals -4, which is also true. That means that the solution is right. So today's lesson was all about how to solve systems of linear equations by graphing. We graphed one of them in each example using the slope and the y-intercept, and we plotted the other one by plugging in some points and finding some points. So I hope you learned a little bit in this lesson, and again, please do not hesitate to reach out to me via email or Canvas discussion boards if you have any questions about this. I will see you later. Hope you have a wonderful day.